Dennis Gordon, for the committee or speakers as a group, you didn't mention it, but in the dietary guidelines, the pre-publication 215, they made a comment that aspartame has carcinogenic properties. Could you comment on the strength of any of those studies? But then my other specific question is the young lady from New York University. Can we assume that all the rodent studies, they control for coprophagy on those animals? They did control for all that? Okay, so that's a serious. And then I'd ask maybe a basic science. The validity, yes, we're changing the microbiota and we're going back and forth. But your opinion on the increase or decrease of the total bacterial mass, your opinion or comment on that? And I know you're at low calorie, so you're not providing any energy. I'm more interested in the energy side, but would you mind commenting on that? Total bacteria. Thank you.
Well, I will address the question on the hematopoietic cancers that the dietary guidelines suggested aspartame might be linked to. First of all, those studies are based on data from the Rabanzini laboratory and have been examined by both FDA and the British Food Standards Association, and in both cases they said that that data was seriously flawed. And if you read Rabanzini's own publication, you will find that the control group, where 0 aspartame was given, have significantly more tumors than were found in the 3 lowest doses of aspartame. So using that data as a suggestion that there might be cancer risk is really, has been disproven. And I think that that was a serious flaw in the assessment of the Dietary Guidelines Committee. So that's obviously I don't feel very strongly about that or anything. And Dr. Ruiz can answer the other questions.
In addition, aspartame, as you cruise through the 70s into the 80s, was regularly claimed to be a carcinogen. In the late 70s, it caused a public board of inquiry to be organized by the FDA, which came down firmly against aspartame being a carcinogen. 1988, a study was published, a poor epidemiologic study claiming that that aspartame growing aspartame use was linked to the incidence of brain tumors. Pretty much every professional and federal organization came out against that study. For some reason, there seems to be a repetitive need to claim that aspartame, which is a dipeptide, is carcinogenic. And don't forget, aspartame is broken down in the small intestine to aspartame, phenylalanine, and methanol in trivial amounts compared to what you eat in your normal diet. So it's not a compound that you would race to think would have any sort of carcinogenic or other, for that matter, effects other than tickling the sweet taste receptor.
Thank you for the question. So the decrease in total bacteria is just at the surface. So it's basically showing that there are alterations in the intestinal microbiota, but its potential effects on energy extraction still needs to be substantiated by looking at short-chain fatty acids or actually doing a transfer experiment.
And the
Oh yes, and the
carcophagy.
I say coprophagy, but yeah. So yes, they never mentioned anything about controlling that, and actually I do a lot of rodent studies, and it's something that's almost impossible to control unless you house each mouse individually.
It should be done.
Oh yeah.
Yep.
I'd just like to add a comment in general to Dr. Ruiz's comments. The Palmina study, which is APM study, was a study where aspartame was put in the water bottle. The investigators didn't know that apparently that rats don't taste aspartame as sweet. So it was basically like giving them water. The dose they were giving, which they said was comparable to what humans take, which is 4 to 5 milligrams per kilogram, that's technically true, but rats metabolize at about 7 times the rate that humans do. So they were actually, if you look at it functionally, their dose level was about 7 times lower than what they said that the rats consumed. They didn't provide any data in that regard. None of the aspartame would actually get into the large intestine, so the cells would not be exposed to any aspartame because it's all broken down to its constituents, as I mentioned a few minutes ago. So, and the animals lost weight. If the FDA were reviewing in a food additive petition a study where the animals lost weight, as was happened in one study with sucralose, they wanted to know, why did these animals lose weight? And so a perfectly reasonable question is, in this study with a homeopathic dose of aspartame, why did these animals lose weight? There's no rational explanation for that. So I think there are a lot of problems with that study. The Abudonia study, which was with sucralose, started at 100 milligrams per kilogram. So it already started at a very, very high dose. And in a lot of studies that are done, the experimenters start at doses that would never be exposed to animals or to humans, obviously, for that matter. And the Suez study, just want to point out that they didn't know anything about the metabolism of these compounds because they said that all the compounds reached the colon and therefore saccharin could represent the others. But saccharin, most of it's absorbed and excreted. Sucralose, most of it does reach the large intestine, and aspartame, none of it does. So there's a real question about exposure to the sweetener in the cecum, to the microbiota, that is a real problem with this study. You could ask the stupid question, why didn't they measure the exposure to these compounds? They should have. I'm not exactly sure how you would do that, but I don't work with the microbiome, and I'd think about it if I did. You'd like to take some of those fecal pellets that they carefully did and look and see how much of the actual sweeteners were there. That tells you, for example, in some of their studies, how much would you incubate the human fecal material in before you went and stuck it in a germ-free mouse. They incubated those cells in saccharin, and they give no rationale for the concentration of saccharin that they use. So these studies have a lot of problems that are fundamentally basic to good experimental design. Those really need to be addressed.
Thank you. Next question.
Hi. Stavros Kavoris, University of Arkansas. I would like your comment about the Pepino study that was published in Diabetes Care in 2013 from some clients group in Washington University, St. Louis, showing that in obese people, sucralose does have an increased glycemic response after 75 grams of glucose administration.
Right, and that's Sam Klein's lab, which is an excellent laboratory. So that's one of the studies where there is some variability in response. So the glucose and insulin response were enhanced, the GLP-1 response was not. And so you see variability in the responsiveness in these individual variables. What I said is basically consistent with the bulk of the studies. The Pepino study is one of the ones that's not totally consistent, but doesn't completely fit the hypothesis. So the hypothesis, as I understand it being put forth, is the sweet taste receptor is tickled, the GLP-1 and 2 come out, they lead to increase in GLP-1 secretion, which enhances the insulin response and enhances uptake into peripheral tissues. GLP-1 mediated for the insulin response, GLP-2 mediated for the uptake of additional glucose that would cause the glucose level in blood to be higher. You get part of that hypothesis fulfilled in that study. You don't get it all fulfilled. So it makes me wonder if that particular hypothesis is actually correct. That's basically the point I'd like to make.
We have a question in the back.
Okay, Robbie Burns with the Grocery Manufacturers Association. I have one question, and it relates to the scientific report of the 2015 Dietary Guidelines Advisory Committee. They state that low-calorie sweeteners are not recommended for use as a primary replacement substitute for added sugars in foods and beverages. In view of what we've heard, and thanks for the excellent presentations, what do you think the basis for their recommendation is? as one part of the question. And the second part is, do you think that basis is enough to reverse decades of work by the food and beverage industry to provide consumers with options with lower calorie density?
Well, I'd like to make just an initial comment, which is I think the basis for it was a unjustified prejudice. Well, let our expert panels make further comments.
I don't think there's any basis for making that statement. I mean, I think you could say a variety of lower calorie. My wife would go, why give them fruit juice? Give them the fruit instead. You don't need to be consuming, and no offense to anybody here who may be interested in fruit juice, but you don't need to be consuming all the extra calories that are in that. So what she would do is balance the intake of fluids over the day, maybe some juice, but certainly some water, and because kids are kids, if they're going to drink a soda, might as well be a non-caloric soda. Why drink a caloric soda? It's a waste of no offense to anybody. It's not a reasonable way to consume calories. And if you believe the hypothesis that you sense liquid calories less well than solid calories, then you may be indiscriminately consuming more calories if you're drinking a regular soda than if you're drinking a non-caloric, obviously, soda. It's just a passive way to consume more calories without thinking about it very much. So common sense to me is any way that I can put fewer calories in a beverage in front of my kid, I will do that just because they tend not to be thinking very carefully at all when they're consuming stuff like that, which is on a frequent basis. I don't know if that gets at your question, but
I'd actually like to make one other comment, which is in several recent studies, one of Deborah Tate and Barry Popkins' lab, and also Gary Foster and Jim Hill in a two-site study, compared the efficacy of giving one group diet sodas and one group water in a weight loss program. And in both cases, the group consuming diet sodas lost more weight. There's also data from the National Weight Control Registry, where people who are very successful weight losers have managed to maintain their weight. People who've lost 70 pounds and kept it off 10 years, they consume 3 times the diet soda, and they state that diet soda helps them to be compliant with their weight maintenance regimen. So I think that, in fact, the data is strongly on the side of low-calorie sweeteners, a useful tool in weight loss and weight maintenance. And for that reason, I really think that the Dietary Guidelines Committee got that part wrong. So, next question.
Yeah, Gerald Bowen. This question is specific to Dr. Fernstrom, and thank you everyone for the nice presentations at this session. I'm very interested in the taste receptor, and thank you for presenting that information. One of the things that's been noticed clinically is that people who take low-calorie sweetened beverages increase their thirst. Is there any work that's been done on the taste receptor and the interaction with thirst?
nothing that I have seen. I haven't seen anything related to that. It may be there, but I really haven't seen it. I've gone through that literature recently in great detail, and I've seen nothing. Anybody else?
Do we have any other questions? Okay, well, I guess I'd like to thank you all for your attention and thank the speakers for truly an excellent presentation. Thank you.